We have learnt about the classification of elements, and in various goals, we learnt about the atomic number, atomic mass and symbols, one letter symbols or single letter symbols, two letter symbols and shells, subshells, and their electronic configuration. Now, particularly to study about the periodic properties. In the periodic properties, we are going to start with goal 1. That is, the introduction to the periodic properties. In this, the property that directly or indirectly depends on the electronic configuration of the element is known as the periodic property. When we look at the word periodic, it means to say that a particular characteristic system is repeated at regular intervals. So, in the periodic table, these intervals are 2, 8, 8, 18, and 32. All the elements which have got a similar valence electron configuration are grouped together under one group. Such elements have similar properties. What is the cause of this periodicity? The cause of the periodicity is the valence shell electronic configuration recurs at regular intervals, either of 2 or 8, 8 or 18, 18 or 32. Because of the recurrence of the valence shell electronic configuration, periodicity occurs. Before we proceed to the main properties, there is a modern periodic law. What does this modern periodic law say? Modern periodic law says that the physical and the chemical properties of the elements are the periodic functions of their atomic number or electronic configuration. It clearly says that the properties directly or indirectly depend on the atomic number or the electronic configuration of the element. This is the modern periodic law. Let's repeat. The modern periodic law says that the physical and chemical properties of the elements are the period functions of the atomic number or their electronic configuration. Let us list down the periodic properties. The periodic properties are: the first one is atomic radii, which is also known as atomic size. Second one is ionization energy. It is also known as ionization potential. Third one is electron affinity. It is also known as electron gain enthalpy. Fourth one is electronegativity. Fifth one is valency. Sixth one is oxidation number. Seventh one is metallic and non-metallic characters. Due to the valence shell electronic configuration or recurrence, these properties repeat at regular intervals, either of 2 or 8, 8 or 18, 18 or 32. What are the uses of knowing the periodic properties? predicting greater or smaller atomic size and radial distribution in neutral atoms and ions, measuring and comparing ionization energies, comparing metallic character with other elements, its ability to form cations, predicting what reaction may or may not occur due to the trends, determining greater cell potential, sum of oxidation and reduction potential between reactions, and completing chemical reactions according to trends. Before we actually go to study the characteristic of the periodic properties, which are also known as the atomic properties, we need to understand two important concepts. They are screening effect, also known as the shielding effect, and the second one is effective nuclear charge. Let us see them. The first one, as we have already quoted, is the screening effect or the shielding effect. As you all know, at the center of the atom, there's a nucleus, and around it are the orbits. In the orbits, the valence electrons are there, designated as K, L, M, N. Now, when we look at the electrons here, there is an attraction. That is, attraction between the valence electron and nuclear charge. At the same time, there is also an electron-electron repulsion because like charges repel each other. The attractive force between the nuclear charge and the valence electrons is reduced due to the presence of the electrons and their repulsive force. This is known as screening effect or the shielding effect. More the number of inner electrons, the greater will be the screening effect value. As a result of this, the valence electrons will always be having the lesser or less attraction between the nucleus and the valence electrons. The second concept is that of the effective nuclear charge. The nuclear charge decreases due to the screening effect. So, due to the presence of the inner electrons, there is a shielding effect, and due to the shielding effect, there is a decrease in the nuclear charge. Now, this resultant nuclear charge is known as effective nuclear charge. Definition of effective nuclear charge. It is the net positive charge experienced by an electron in a multi-electron atom. We will see a simple equation here. Effective nuclear charge is represented by Z star, which is equal to Z minus sigma. Now, Z star is the effective nuclear charge. Z is the actual nuclear charge, and sigma is the screening effect. Sigma can be found by using quantum chemistry and the Schrödinger equation, or by using Slater's empirical formulas. So, due to the screening effect, the actual nuclear charge decreases. This decreased or the resultant nuclear charge is known as the effective nuclear charge. The effective nuclear charge experienced by the outer shell electron is also called the core charge. It is possible to determine the strength of the nuclear charge by the oxidation number of the atom. With this, we conclude the introduction.